The third and final averaging technique we're going to look at is called the exponential smoothing forecast. To do this type of forecast, you take the previous forecast and then you add the product of the forecasting error multiplied by the smoothing constant. Let's take a closer look at the smoothing constant and the forecasting error. First, let's take a look at how you calculate the error. Forecasting error is really nothing more than the actual value minus your previous forecast. Say for period 10, you forecasted 5. And then at the end of period 10, you find out that the actual amount was 8. The forecasting error is simply 8 minus 5, which gives you 3. Now let's take a look at the smoothing constant, which is represented by alpha. The smoothing constant is a number between 1 and 0 that is used to guide decision making. The smoothing constant affects the forecast in several different ways. If the constant is closer to 0, the forecast will be more smooth. If the constant is closer to 1, the forecast would be much more jagged. Another way to look at this is if the smoothing constant is closer to 0, the forecast is less responsive. On the other hand, if the constant is closer to 1, the forecast is much more responsive. Before we do an exponential smoothing example, let's take a look at the information we just covered in graphical form. In this example, we have the actual data marked in black. And once again, the data is very rigid due to its irregular and random variations. And then we have an alpha that's close to 0, marked in red, and another smoothing constant closer to 1, marked in blue. Just as we said in the previous slide, a smoothing constant closer to 0 is smoother but less responsive. And a smoothing constant closer to 1 is more rigid but more responsive. And you can see this in the graph. This is much more rigid, and it is much more responsive to the actual data marked in black when compared to the forecast in red, which uses a smoothing constant closer to 0. This is much more smooth, but it's much less responsive to the data. Okay, now let's take a look at an example. Here we are asked to forecast for September sales using the exponential smoothing method, which has a smoothing constant equal to 0.20 and assuming a March forecast of 19,000. Something that would be helpful to put on your cheat sheets would be the formula found on page 89 of your textbook. In this case, FT is what we're trying to forecast for in September. FT minus 1 is given by the initial forecast for March. The alpha is given to be 0.20, and we know how to do the error, which is the actual minus the forecast. So let's see this in action. Once I know that I need to conduct an exponential smoothing forecast, the first thing I would do would be to write out the formula. The problem stated that the alpha is 20% or 0.2, and the forecast for March was 19. We can now start using the formula to guide us to the exponential smoothing forecast. The first thing we need to do is to calculate the error by taking the actual value minus the forecast value, which in this case would be equal the actual sales were 18 minus the forecasted sales of 19. We then need to multiply this by alpha. In Excel, we can do that by multiplying 1 by 0.2. And then here, make sure to lock the value on a Mac. You do Command T to make it easier in the long run. Now we can start forecasting. To forecast April, we know that FT is April. And FT minus 1, which is March, plus the smoothing constant times the error, which we have in this column. So let's do it. The forecast for the previous month plus the alpha times the error. And we get 1880. And now we can use the formulas that we entered and fill down each column to get the forecast for September. And the exponential smoothing forecast for the month of September is 19.26.